Most people discover it accidentally. They lift an arm toward a mirror, a sleeve slides downward, and beneath the tricep, the tissue moves half a second later than the bone beneath it. Not large movement, not obesity, just a soft delay, a kind of mechanical lag, and almost instantly the brain assigns a verdict. But in laboratories studying connective tissue aging, muscle denervation, collagen remodeling, and mechanobiology, researchers have spent decades documenting something far stranger. In many cases, the tissue hanging beneath the arm is not primarily an energy storage problem. It is a signaling problem, a structural problem, a tension problem. The arm did not simply accumulate mass. It lost conversation with gravity. The distinction matters, because fat behaves differently than disconnected tissue. Fat has density, blood supply, metabolic activity. But the sagging most people notice in the posterior arm often emerges from another process entirely. Loss of muscular tension, fascial stiffness, collagen orientation, vascular perfusion, and neural recruitment. The scaffold weakened, the tissue followed. And modern life accelerated the process silently. Not through age alone, through mechanical silence. Your tissue is listening. Most people think arms become loose because tissue melts with age. The evidence says otherwise. At the microscopic level, the body is constantly rebuilding itself. Muscle proteins turn over. Collagen fibers reorganize. Fascia adapts to loading patterns. Blood vessels expand or regress according to demand. Even fibroblasts, the cells responsible for maintaining connective tissue, alter their behavior depending on tension exposure. Cells obey mechanics. Remove the signal, and the architecture changes. A 2006 series of mechanotransduction studies from Harvard and MIT demonstrated that cells interpret force almost like language. Mechanical loading altered gene expression directly through the cytoskeleton. Not metaphorically, literally. Tension changed cellular decisions. And nowhere is this more obvious than the human arm, because the tricep exists in a strangely neglected territory of modern movement. Humans evolved pulling, climbing, carrying, reaching, hanging, throwing. The posterior arm once lived under constant load variability, compression, tension, deceleration, suspension. Now the arm mostly floats in front of glowing rectangles, elbows bent, shooters internally rotated, posterior chain dormant. The tricep no longer stabilizes body weight. The fascia no longer experiences longitudinal tension. Blood perfusion decreases. Muscle recruitment narrows. And over years, the tissue changes identity, not suddenly. Gradually enough that the nervous system accepts the collapse as normal. The frightening part is this. Most people never lost strength first. They lost tension first. There is a difference. Muscles are not merely engines. They are signaling organs. Every contraction sends information through fascia, tendon, periosteum, vascular tissue, and the nervous system itself. Movement is biochemical communication. Without tension, cells stop investing in structure. Aging research from the University of Pittsburgh and Tufts has repeatedly shown that sarcopenia, age-related muscle decline, begins decades before visible weakness. MRI scans reveal reductions in muscle quality and motor unit recruitment long before major mass loss appears externally. The tissue stopped organizing itself efficiently, not because the body is lazy, because adaptation is expensive. Biology conserves resources ruthlessly. Unused tissue becomes downgraded tissue. And the underside of the arm is especially vulnerable, because it depends heavily on eccentric loading, the controlled lengthening of muscle under tension. Most modern movement avoids this entirely. People push objects occasionally. They almost never resist gravity slowly. But eccentric loading is where connective tissue receives some of its strongest structural signals. In 2001, researchers studying tendon adaptation found that slow eccentric contractions dramatically increased collagen synthesis compared to passive movement alone. The fibroblasts responded almost immediately to directional tension. The scaffold thickened under stress. Without stress, it unraveled. This is why many thin individuals still develop hanging arm tissue. The issue is not always adipose accumulation. Sometimes the muscle beneath has flattened neurologically. The fascia has stiffened irregularly. The collagen matrix has lost directional organization. And the skin itself, deprived of mechanical support, begins draping over silence. Stillness has consequences. Try something. Extend your arm outward, relax completely. Now lightly tap the underside of the arm. Notice the oscillation, then tighten the tricep hard. Tap again, the tissue changes instantly. Not because fat disappeared, because tension reorganized the structure beneath the skin. This is one of the least understood realities in fitness culture. SHOP is often mechanical before it is metabolic. The body is a tensegrity system, not stacked blocks, not isolated muscles. A continuous network of force distribution. Architecture researchers and biomechanists use the word tensegrity to describe structures stabilized through balanced tension and compression. Human fascia behaves similarly. The body maintains shape through distributed mechanical relationships. When tension disappears from one region, neighboring tissue compensates. Shoulders collapse inward. Upper back weakens. The arm hangs differently from the scapula itself. Then gravity begins exploiting the silence, slowly. Year after year, most people attack this with random repetitions, tiny pink dumbbells, hundreds of arm circles, endless low-resistance movement. But tissue does not respond emotionally, it responds mechanically. The cells require specific inputs, look magnitude, time under tension to lengthened contraction, perfusion neural recruitment. Without these, the body has no reason to rebuild posterior arm architecture. Exercise is not punishment. It is instruction, and most instruction being given to the tricep is biologically meaningless. The nervous system adapts first, long before visible tissue changes. A famous series of experiments by Russian physiologist Yuri Kotz demonstrated that early strength gains in humans occur primarily through neural adaptation rather than hypertrophy. Motor unit synchronization improves. Recruitment efficiency rises. The brain learns access. The muscle is not absent. It was unavailable. This matters because many sagging arms are partially neurological. The posterior chain becomes under-recruited through years of forward-dominant living, typing, driving, scrolling, sitting. The brain allocates less precision to neglected tissue, movement maps shrink, and once neural recruitment decreases, blood flow often follows. Perfusion is not constant throughout the body. Capillary density adapts to usage patterns. A poorly recruited muscle receives weaker circulation over time. Oxygen delivery changes. Nutrient signaling shifts. Waste clearance slows. At the tissue level, stagnation begins feeling normal. Then people blame age. But age alone does not explain the speed of decline seen in industrialized populations. Hunter-gatherer movement studies show dramatically different preservation of upper body tissue integrity into older decades, despite minimal exercise in the modern sense. Because the body evolved under varied mechanical demands, not repetitive stillness, not ergonomic paralysis. Mechanical diversity once protected connective tissue. Now chairs remove it, screens remove it. Convenience removes it. And the body adapts honestly, not cruelly. Honestly. There is another layer beneath this. Skin itself is mechanically intelligent. Most people imagine skin as passive wrapping. It is not. Skin cells respond continuously to tension, hydration, circulation, ultraviolet exposure, hormonal shifts, and movement patterns. Fibroblasts within the dermis regulate collagen and elastin production according to mechanical environment. In 1987, research into skin expansion techniques showed that sustained tension could stimulate actual tissue growth and remodeling. Surgeons used controlled stretching to generate additional skin for reconstructive procedures. The skin interpreted tension as instruction. Absence of tension also becomes instruction. Over decades, reduced mechanical stimulation contributes to collagen disorganization. Elastin fibers fragment. Cross-linking changes. Water retention capacity declines. The surface begins reflecting the silence beneath it. Not instantly, incrementally, one collagen fiber at a time. And then there is estrogen, a hormone often blamed simplistically for body changes, yet rarely understood biomechanically. Estrogen influences collagen metabolism, connective tissue elasticity, vascular function, and fat distribution. During perimenopause and menopause, reductions in estrogen can accelerate connective tissue changes dramatically. Research published in the early 2000s demonstrated measurable reductions in skin collagen content within the first 5 years after menopause. But even here, movement changes the outcome. Mechanical loading stimulates anabolic signaling pathways independent of hormonal decline. Resistance training increases local growth factors, improves circulation, and preserves tissue integrity even in aging populations. The body remains responsive not infinitely, but profoundly. Cells obey mechanics. Which brings us to the real question. What actually restores the arm? Not cosmetically. Structurally, the answer begins with a contradiction. Most people train the arm by shortening it repeatedly. Quick pushdowns, tiny contractions, minimal stretch, but connective tissue adaptation often requires loaded lengthening. The tissue must experience controlled elongation under force. This is why certain exercises consistently outperform others in both hypertrophy and structural remodeling studies. Not because they burn, because they load tissue deeply. The first movement is deceptively simple. Overhead tricep extensions, not performed casually, performed slowly. The arm elevated fully overhead changes the mechanics entirely. The long head of the tricep crosses the shoulder joint, meaning it experiences maximal stretch only when the arm rises upward. Suddenly the neglected fibers lengthen under load. Fascia tensions longitudinally, blood flow increases. Motor units awaken deeper in the tissue. The muscle begins receiving a message it has not heard in years. Build here, a 2022 hypertrophy study, comparing lengthened position training versus shortened position training, found significantly greater muscle growth when exercises emphasized loaded stretch positions. The signal was stronger in the elongated state, because tissue remodeling responds intensely to mechanical strain gradients. The scaffold listens most carefully when tension deepens. Perform the movement slowly enough, and another process emerges. Mechanotransduction. Tiny proteins within cells physically deform under load, converting mechanical force into biochemical signals. mTOR pathways activate. Protein synthesis increases. Cytoskeletal remodeling begins. Exercise is chemistry through force, not motivation. Force. The second movement appears almost primitive. Bodyweight support, wall presses. Incline push-ups. Counter push-ups progressing toward floor push-ups. Not because push-ups are magical, because the human arm evolved under closed-chain loading. When the hand fixes against a surface and the body moves around it, the nervous system recruits stabilizers differently. The scapula engages. The posterior chain activates collectively. Tension distributes through fascia instead of isolating single muscles artificially. The arm remembers older mechanics, your tissue remembers history. Closed-chain loading also increases co-contraction around joints, improving structural integrity. Tendons receive multidirectional forces. Bone density signaling improves through compressive loading. The body begins rebuilding not merely muscle, but coordination. And coordination changes appearance faster than many realize. Because hanging tissue often reflects disorganization more than sheer mass. The third movement is rarely discussed in conventional fitness culture. Hanging, even partial hanging, scorted hanging, suspension. The shoulder complex evolved for suspension mechanics, yet modern humans almost never hang anymore. As a result, fascial lines shorten adaptively, the lats weaken, scapular positioning deteriorates. The arm loses vertical tension exposure entirely. But during hanging, something extraordinary happens. The connective tissue network elongates globally. Grip activation irradiates neural tension upward through the arm. Blood vessels experience altered hydrostatic dynamics. Decompression occurs through the shoulder girdle. The body experiences ancient information. Support your weight. Organize under gravity. Several rehabilitation researchers have observed improvements in shoulder function and tissue tolerance simply from progressive hanging exposure. Not aggressive hanging. Gradual exposure. Again, the principle is not punishment. It is reintroduction. Modern life removed certain mechanical conversations. The body adapted accordingly. There is also the issue of tempo. Speed hides weakness. Momentum hides silence. Most people move too quickly to allow tissue adaptation. Slow eccentrics change this immediately. Take 5 seconds lowering the weight during a tricep movement, and something uncomfortable appears. Tremor, instability, fragmented recruitment. The nervous system exposes regions it cannot coordinate smoothly. That trembling is not failure. It is information, the brain rebuilding access. Studies on eccentric training repeatedly show superior connective tissue adaptation, increased hypertrophy signaling, and improved tendon resilience compared to concentric dominant movement alone, because tissues strengthen while resisting collapse, not merely creating force. There is philosophy hidden inside physiologies. The body does not maintain what reality no longer requires. This principle governs everything from bone density to cardiovascular capacity to neural precision. Adaptation is negotiation with environment, and modern environments ask very little from the posterior arm, so the body reallocates resources elsewhere, not maliciously economically. The tragedy is that most people interpret this adaptation morally, as personal failure, but biological systems do not care about shame, only signals. One of the most revealing experiments in physiology came from limb immobilization studies. Researchers found measurable muscle atrophy within days of unloading. Insulin sensitivity changed, neural recruitment declined, protein synthesis dropped rapidly. The body was not waiting passively. It was actively adapting downward. Now extend this process across decades of low tension. The outcome becomes visible beneath the arm. Mechanical silence accumulates. And then there is inflammation. Not dramatic inflammation. Quiet inflammation, low-grade chronic inflammatory signaling associated with sedentary behavior, poor sleep, stress, hyper-processed diets, and metabolic dysfunction can impair collagen integrity and muscle recovery subtly over time. Cytokines alter tissue remodeling. Fibroblast behavior changes. Repair slows, the scaffold becomes harder to maintain. Yet movement itself alters inflammation profoundly. Contracting muscle releases myokines, signaling molecules capable of influencing systemic metabolism and inflammatory regulation. Skeletal muscle behaves almost like an endocrine organ. Movement changes chemistry. This is why resistance training consistently improves not just strength, but skin quality, insulin sensitivity, vascular health, mitochondrial function, and connective tissue resilience across aging populations. The body responds globally to local force. A tricep extension is never just a tricep extension. It is a molecular event. And perhaps the most overlooked factor of all is blood. Not circulation in the abstract, perfusion at the capillary level. Sedentary tissue often becomes underperfused. Nutrient exchange weakens. Oxygen gradients shift. Waste metabolites linger longer. The tissue environment changes silently. Then resistance training begins. And suddenly blood returns, capillaries expand. Endothelial function improves. Nitric oxide signaling increases. The tissue warms differently. People often describe this as a tone change. But underneath the cosmetic observation, infrastructure is returning. The city is rebuilding roads. Your arm is not merely shrinking or tightening. It is reorganizing. And reorganization takes time because connective tissue remodels slower than muscle. Collagen turnover can require months. Tendons adapt gradually. Fascia changes through repeated loading patterns over long durations. This is why random intensity fails. Consistency matters because biology trusts repetition. One workout is noise. Repeated tension becomes policy. The body begins asking, should this structure be preserved again? And eventually, if the signal persists, the answer changes, yes. Build here. There is an experiment you can perform right now that reveals how rapidly tissue responds to mechanics. Stand naturally, and allow your shoulders to collapse forward. Observe the underside of the arm. Then externally rotate the shoulders gently, lift the sternum slightly, and engage the upper back. Without losing a single gram of fat, the tissue appearance changes instantly. Why? Because structure determines drape. Posture is not merely aesthetic positioning. It changes force distribution across the fascial network. The arm hangs from the scapula. The scapula depends on thoracic mechanics. Thoracic mechanics depend on breathing patterns and spinal positioning. Everything connects. A collapsed ribcage changes shoulder mechanics. Altered shoulder mechanics reduce posterior arm loading. Reduced loading weakens connective support. Tissue begins sagging beneath altered architecture. The arm was never isolated. Nothing in the body is isolated. This is why restoration protocols that focus only on burning arm fat often fail psychologically. People chase metabolism while ignoring mechanics. But tissue shape is partly geometric, partly neurological, partly vascular, partly connective. The body is a layered system of adaptation, and every layer listens to force. Researchers studying astronaut deconditioning discovered how brutally fast the body remodels without gravity exposure. Muscle mass decreases, bone density falls, connective tissue changes, neural coordination deteriorates. Gravity itself is biological information, which means every time you resist gravity intentionally, the body interprets meaning, not emotionally, structurally. The exercises that matter most are not the ones creating exhaustion. They are the ones restoring conversation between tissue and load. Overhead extensions, slow push-ups, supported hangs, eccentric lowering, scapular stabilization, not random movement, specific mechanical dialogue, and perhaps the most important detail is progression. Cells adapt to novelty, then normalize it. A resistance band eventually becomes insufficient. Light dumbbells stop generating meaningful strain. The nervous system economizes familiar movement, so the signal must deepen gradually, not violently, progressively. Biology respects progression because evolution itself operates through incremental adaptation. Too little tension and nothing changes. Too much tension and tissue protects itself. The ideal signal sits between comfort and threat. This is where remodeling happens. Aging itself begins looking different once this is understood, not as passive decay, but as cumulative adaptation to repeated conditions. Researchers studying centenarians often note enormous variability in tissue quality among people of identical chronological age. Some retain remarkable connective integrity. Others decline rapidly. Genes matter, hormones matter, nutrition matters. But movement history matters profoundly. The body records behavior mechanically. Tissue memory is real, not mystical memory, structural memory. Collagen aligns according to repeated stress patterns. Fascia thickens where force travels repeatedly. Neural maps strengthen through usage frequency. The body becomes what it rehearses, and modern life rehearses stillness relentlessly. Horse seated, arms unsupported, minimal overhead movement, minimal pulling, minimal suspension. The posterior arm slowly disappears from the brain's priority map. Then one day the mirror reveals the consequence. But mirrors only show the surface. Underneath, entire biological systems have already adapted. The hopeful part, though hope is too sentimental a word, is that adaptation works both directions, not perfectly, not infinitely, but measurably. Studies on resistance-trained elderly populations repeatedly show increases in muscle thickness, tendon stiffness, insulin sensitivity, mitochondrial density, and connective tissue resilience even in advanced age. The machinery remains responsive far longer than culture assumes, because living tissue remains alive, and living tissue listens. One of the most fascinating findings in mechanobiology is that cells often respond less to duration than to dynamic change. Variation matters, oscillation matters, rhythmic loading matters. This is why walking alone rarely restores posterior arm structure effectively despite its cardiovascular benefits. The tricep requires directional strain, elongation, stabilization, compression, suspension. Specificity governs adaptation. The body changes according to the exact forces imposed upon it, not intentions, not wishes, forces. This realization can feel strangely emotional, because it reframes the body entirely. The body is not a cosmetic object failing to satisfy cultural standards. It is a predictive adaptation engine, continuously asking, what environment am I preparing for? And if the answer remains sit still, the tissue reorganizes around stillness, economically, efficiently, honestly, not age. Input. There is a reason physically active older adults often possess dramatically different arm tissue despite similar body fat percentages. The distinction lies in structure, muscle thickness, collagen integrity, neuromuscular recruitment, fascial tension, circulatory efficiency. The scaffold remained active, and active scaffolds support tissue against gravity. This is why the goal should never be merely smaller arms. Smaller tissue can still hang if structure beneath it remains mechanically silent. The objective is restoration of tension architecture, a living scaffold beneath the skin. And this requires patience because connective systems move slower than human emotion. People want immediate visual proof. Biology prefers repeated evidence. A tendon does not trust one workout. A fascia line does not reorganize overnight. A neural pathway does not strengthen through occasional effort. Adaptation requires consistency, because consistency proves environmental change is real. The body is conservative. It waits before investing resources. Then gradually, almost invisibly at first, the tissue begins responding. A little more density, a little more tension, a little more structural coherence. The arm starts moving differently before it looks different. And this may be the deepest misunderstanding in modern fitness culture. The visual transformation is usually preceded by invisible organization. First, the nervous system changes, then recruitment changes, then circulation changes, then connective behavior changes, then shape changes. The mirror witnesses the final chapter, not the beginning, which means many people quit during the biological prologue. They stop before the infrastructure forms. But tissue adaptation has always been slow, because stable systems cannot remodel recklessly. Your biology values survival more than aesthetics, and survival requires caution. The remarkable thing is that even now, beneath years of mechanical silence, the machinery is waiting. Fibroblasts still respond to tension. Muscle fibers still hypertrophy under load. Capillaries still proliferate with demand. Neural maps still reorganize through repetition. The conversation can resume, not because the body suddenly becomes young again, because living systems remain adaptive until death. That is their defining characteristic. Adaptation. The sagging arm was never merely an appearance problem. It was evidence of altered mechanics, altered loading, altered signaling, altered conversation between tissue and environment. The body was documenting your lifestyle physically, quietly, faithfully. And once you understand this, something changes psychologically, not motivation, recognition. You stop viewing the body as an enemy mysteriously collapsing with time. You begin seeing a responsive organism negotiating with conditions. Every hour of stillness communicates. Every repetition communicates. Every load communicates. Your cells are listening continuously. The final irony is that many people spend years trying to punish tissue that was only adapting intelligently. The arm did not betray you, it economized. It followed the laws governing all living structure. Unused architecture decays, loaded architecture reinforces, signals shape biology, and beneath the skin, beyond mirrors and aesthetics and cultural shame, the truth remains brutally simple. Cells obey mechanics, not the clock, the environment. There is another reason the underside of the arm changes before many other regions of the body. It has unusually little structural forgiveness. The posterior upper arm is suspended between multiple competing systems. The tricep, the brachial fascia, the skin envelope, lymphatic drainage pathways, and the shoulder girdle above it. Unlike the glutes or thighs, which possess larger muscle mass and broader connective anchoring, the arm depends heavily on tension continuity. Small losses become visible quickly. A slight reduction in tricep thickness, a slight decline in collagen organization, a slight forward rotation of the shoulder, and suddenly gravity gains leverage. This is why the problem often accelerates after periods of inactivity, illness, emotional stress, or rapid dieting. Not because the body became weak overnight, because connective systems destabilize simultaneously. Rapid weight loss is one of the clearest examples. People celebrate shrinking measurements while silently losing structural support beneath the skin. Muscle protein breakdown increases under caloric restriction, especially when resistance loading is absent. Collagen turnover suffers when protein intake declines. Hydration changes alter fascial glide. The volume disappears faster than the scaffold can reorganize. And the skin, no longer mechanically supported, begins hanging over underloaded tissue. Researchers studying bariatric surgery patients documented this repeatedly. Massive fat reduction alone did not automatically restore tissue tightness. In many cases, skin elasticity, muscle preservation, and connective adaptation determined outcomes more strongly than weight itself. Smaller is not always structurally stronger. The body can become lighter while becoming mechanically emptier. And emptiness has texture. You can feel it during movement, a soft instability, a delayed recoil, an absence of spring. Young tissue behaves differently, not simply because it contains more collagen, but because the collagen remains organized under regular tension exposure. Elastic fibers recoil rapidly. Interstitial fluids move efficiently. The fascia slides with less resistance between layers, healthy tissue glides, degenerated tissue drags. This distinction becomes visible during ordinary motion. Watch the arm of a physically active climber in their 60s, beside the arm of a sedentary individual decades younger. The difference is not merely age or body fat percentage. It is tissue behavior. One arm behaves like loaded architecture. The other behaves like unsupported fabric. And the nervous system sits underneath all of it like an invisible conductor. Because movement quality is partially a prediction problem, the brain constantly anticipates force demands. If certain movements disappear from life for years, the nervous system reduces investment in those patterns. Motor cortex representation changes. Coordination degrades. This phenomenon is called use-dependent neuroplasticity. The body allocates precision where life requires it. A pianist develops extraordinary finger mapping. A climber develops immense grip integration. A sedentary worker develops thumb-scrolling efficiency and forward neck stabilization. The nervous system adapts honestly to repeated demand, which means many arms are not merely deconditioned. They are neurologically simplified. The brain stopped expecting the arm to encounter meaningful resistance, and once expectation changes, recruitment changes. This explains why the first weeks of proper loading often feel strangely exhausting despite minimal weight. People assume they are training muscle. In reality, they are reactivating dormant coordination. The nervous system is rebuilding forgotten pathways. You can observe this immediately during slow eccentric push-ups. The shaking appears before fatigue should logically occur. Tiny stabilizers activate asynchronously. Force leaks through weak fascial integration points. The body exposes its missing conversations. But trembling is adaptation beginning. Researchers using electromyography repeatedly show that slow controlled resistance dramatically increases motor unit participation compared to passive or momentum-based movement. The nervous system wakes in layers. And beneath that neural awakening, circulation changes almost immediately. Blood vessels are not passive pipes. They remodel according to demand. Endothelial tissue senses shear stress from increased blood flow and responds by improving vascular function. Movement literally teaches arteries how to behave. Nitric oxide production rises. Capillary density can increase. Perfusion improves. The tissue receives better infrastructure. This matters because poorly perfused tissue ages differently. Oxygen delivery influences mitochondrial function. Nutrient exchange affects protein synthesis. Waste clearance influences inflammation. Biology depends on logistics. The body is an ecosystem of transport networks, and sedentary tissue slowly becomes biologically underfunded. Then resistance training begins restoring traffic. The arm warms more easily. Recovery improves. Skin coloration changes subtly. Tissue density shifts. Most people notice appearance first. But appearance is downstream from physiology. Everything visible began invisible. This is the central misunderstanding of the human body. People think aesthetics are cosmetic. In reality, aesthetics often reveal infrastructure quality. A dense-looking arm usually reflects coordinated loading histories, vascular adaptation, connective integrity, and neuromuscular efficiency accumulated over years. The surface tells the story of repeated signals underneath, and signals become structure. One of the strangest discoveries in fascia research emerged from dissections, showing that connective tissue is far more densely innervated than previously believed. Fascia contains sensory receptors capable of influencing proprioception, pain perception, tension regulation, and movement coordination. The body does not merely move through fascia. The body perceives through fascia, which means chronically unloaded tissue changes sensory experience itself. Movement becomes less precise, position awareness dulls, stability decreases. The arm begins feeling less integrated into the whole body. This is why restoration protocols must include more than isolated contractions. The tissue requires contextual loading, carries pull-ups, pulling patterns, overhead stabilization. The body relearns integration through complexity. One particularly effective intervention is loaded carries, Sybil movement, extraordinary consequences. Holding heavy objects while walking forces the arm to stabilize continuously against oscillation. Grip irradiates tension upward through the forearm and shoulder complex. The scapula organizes reflexively. Core musculature coordinates automatically. Suddenly the arm is no longer decorative tissue. It becomes functional architecture again. Farmer's carries, suitcase carries, overhead carries. These movements recreate ancient mechanical demands humans evolved under for hundreds of thousands of years. Transport support. Suspension. The body recognizes these patterns immediately because they are evolutionarily old. Modern gym culture often isolates muscles too aggressively, forgetting that the nervous system evolved integrated movement first. Real tissue thrives under coordinated tension, not fragmented contraction alone. This is why physically laboring populations historically displayed dense connective integrity without formal arm workouts. Their tissue experienced endless low-level variability, pulling ropes, carrying loads, climbing, digging, stabilizing. Mechanical diversity preserved structural coherence. Now compare that to modern office life: static chair, minimal load variation, arms supported constantly, very little overhead movement, almost no hanging, almost no carrying. The body receives radically less information, and biological systems deprived of information begin simplifying themselves. This principle appears everywhere in physiology. Astronauts lose bone density in microgravity because bone requires compression signaling. Bedridden patients lose muscle astonishingly quickly because unloading suppresses anabolic pathways. Even the cardiovascular system weakens under prolonged inactivity because the heart adapts downward to reduce demand. The body is not failing, it is reallocating. This realization becomes almost philosophical, because humans often imagine identity as fixed while biology remains fluid. But your body is less like a sculpture and more like weather. Responsive, adaptive, continuously negotiating with environment. The arm hanging beneath the shoulder is not random misfortune. It is accumulated adaptation made visible. And perhaps the most unsettling aspect is how silent the process is. There is rarely pain early on. No dramatic injury. No catastrophic event. Only tiny reductions repeated thousands of times. Less reaching. Less pulling. Less carrying. Less resistance, less tension, until eventually the scaffold itself begins withdrawing support. The tissue followed. There is an experiment performed in mechanobiology laboratories, using cultured cells, placed onto surfaces of different stiffness. Identical cells behave differently, depending on the mechanical environment beneath them. On soft surfaces, cells spread differently. On rigid surfaces, they organize differently. Some even differentiate into entirely different tissue types. The implication is profound. Cells are not merely genetically programmed. They are mechanically educated. Your environment enters biology through force. Which means the modern human body is being educated by chairs, screens, steering wheels, keyboards, couches, and armrests for most of its waking existence. Stillness becomes curriculum. And the body learns accordingly. This is why aggressive short-term exercise often fails to fully restore tissue quality. The body spends 23 hours receiving one message and 1 hour receiving another. Biology trusts the dominant signal, so restoration requires environmental redesign as much as exercise itself. More carrying, more reaching, more standing, more overhead motion, more varied loading throughout the day. Not because movement burns calories, because movement restores conversation. The body evolved expecting continual mechanical dialogue. When dialogue disappears, tissue becomes quieter. The posterior arm is one of the first places this silence becomes visible. And then there is sleep, an underestimated regulator of tissue integrity. Growth hormone secretion increases during deep sleep phases. Protein synthesis accelerates. Tissue repair intensifies. Connective remodeling depends heavily on recovery physiology. Chronic sleep restriction alters collagen turnover, glucose regulation, inflammatory signaling, and muscular recovery. The scaffold repairs itself poorly under exhaustion. Modern life often combines sedentary behavior with sleep deprivation, a biologically destructive pairing. The body receives weak loading during the day and inadequate recovery during the night. Then people wonder why tissue quality deteriorates despite occasional workouts. But adaptation always reflects the total environment, not isolated effort. There is also the issue of protein itself. Muscle and connective tissue are built from amino acids. yet many aging adults progressively consume less protein precisely when anabolic resistance increases with age. This phenomenon is deeply important. Older tissue often requires stronger signals to stimulate protein synthesis effectively. Researchers studying aging muscle repeatedly observe that elderly individuals need higher quality protein intake and resistance training intensity to preserve lean tissue. The machinery still works, but the threshold rises, which means passive living becomes increasingly costly over time. The body stops maintaining expensive tissue unless clear demand persists. Again, not age alone. Input. The most powerful exercises for sagging arms are not magical because of calories burned. They are powerful because they restore mechanical relevance to neglected tissue. The body asks, will this structure be needed again? And if the answer becomes consistently yes, biology reallocates resources, slowly, reluctantly at first, then increasingly. This is why visible change often accelerates after several months, rather than several days. Early adaptation is infrastructural. Neural efficiency improves. Blood flow increases. Connective tissues strengthen gradually beneath the surface. Only later does the architecture become externally obvious. The body rebuilds foundations before facades. And perhaps that is the deepest lesson hidden beneath the sagging arm. Living systems prioritize function before appearance. Always the mirror sees shape. Biology sees survival. But survival itself depends on mechanics, on tension, on load, on repetition, on signals. The arm did not collapse because time passed. It collapsed because the conversation changed. And once the conversation changes again, tissue begins listening immediately. Not emotionally. Mechanically, cells obey mechanics.